What's up, everybody? Mark Price here at devslopes.com, and here we go again, finishing or continuing our project here. And let's see what we have so far. We've got an animating zombie. We got some rocks. Our zombie's a little bit handicapped. It's like, one of those little kittens, that's like trying to climb up something that keeps falling, or a little dog that's like missing a leg and it can't move right or something. That's what our zombie's like right now. It's like one of those. So what I want to do in this one is I would like to get some physics going, and what I mean is I'd like to get the zombie interacting with the obstacles. I'd like to get some force to the zombie where he's actually moving, and I think that'll be a good start. So let's go ahead and do that. Well, how do we do that? How do we introduce physics into our game? And now, one thing that we need to talk about before we actually jump into physics is, do we have to use physics for our game? And the answer is no. We actually could write code to simulate physics, like making a character jump, kind of like they did in Mario Brothers, the original Mario Brothers on NES. Now, there was no physics. It was simulated physics. You would press a button, and over X amount of milliseconds while he's jumping, it would add some velocity, okay, or add some force. And then depending on how long you press the button as well too, if you tapped it really short, it was a little jump. If you tapped it and held it for a while, it was a bigger jump. Of course, that had to cap off at some point. Can't just hold it forever and float into the air. So if you held it for the longest duration, he'd have the highest jump, and then he only has a certain limit which he can jump before he comes down. And all that was actually hand-coded, and we could do that. But I think there's an easier way and a better way. We'll use some actual physics in our game. And you don't have to do anything special to enable physics. They're already kind of there. But we do have to make our objects physics enabled. And so what we're going to do is we're going to select our zombie here. Okay, this is our player. And for some reason, my screen got moved around a little bit. That's okay. We'll just leave it here. And so we got our player object. And what I want to do is go to Component, Physics, and add a Sphere Collider. Okay? As you can see, there's this little sphere, green sphere underneath him. Now, it's not quite where it needs to be, so let's move it. Let's move its center up into the zombie like so. It's a little bit small, so let's also increase the radius to about right there. Now, this is important, making sure that you have your physics correctly set, or your collider correctly set for your object. If you made it too big, players would be angry because they got really close to an edge and they shouldn't have hit it, because clearly on the model, there was no reason why you should hit it. So this is very important, making sure your colliders properly match. I think ours is okay. Maybe we could adjust a little bit, but I don't see anything noticeably wrong here. But you could always play it safe, by like just making it a tiny bit smaller, like so, and let it dip into the mesh a little bit when it hits an object. Okay, so we've got a collider here on our zombie, but what about our obstacles? Okay, so let's look at those. We got 3 of them. All right. Here's our rock. Okay, now our rock does not have a collider. So if I go to Component, Physics, let's just add a box collider in this case here. And the reason why I'm adding a box collider, because it kind of it fits it okay. There's nothing too special I need to do with it. I might make this a tiny bit smaller, maybe on the x-axis. By the way, on this x here, I'm just clicking and dragging, which is why it's shrinking. See? Okay? I'm not actually typing in numbers. I'm just adjusting it here. And maybe we'll just slightly decrease the height. Okay, but it's looking pretty good. And obviously, we need to do it on these ones here. And I realized that we actually never made these other rocks prefab, so we'll have to do that in a minute here. But let's just see what happens. I've added 2 colliders. What do you think is going to happen? So here's my stumpy little zombie who can't move. Okay, he just hit it and nothing happened. Nothing happened at all. Really interesting. Why? Well, we have a collider, but our object still is not affected by physics. So what we need to do is select our player again. And this time we're going to go to Component, Physics, and a rigid body. And what a rigid body is, it's a component that allows an object to be affected by the world of physics. Okay? And here's a few properties on it. We've got mass. That's how heavy an object is, right? Drag is what is slowing it down. Okay? So, a bird has drag when it's floating down. because its wings are out, and so the wings are causing drag, so it doesn't fall as fast. Okay, whereas a bowling ball would not have that drag; it would fall much quicker because there's nothing pushing against it. An angular drag is the drag on rotation. So like let's say you punted a football and it's spinning. Well, the more angular drag you have would be the more resistance against the spin you would have, so it would spin slower. Okay, so think of drag as resistance and angular drag as resistance against rotation. Use gravity. That's saying, hey, gravity's on, so you're gonna fall. Okay, this object's gonna fall with this on. Okay. And we'll talk about the other ones here in a minute. So let's just click play to make sure he falls. Boop. He's in the lava and he's dead. Well, not quite, but so it definitely is working. Okay, use gravity, definitely working. So if I turn it off and then I click play. All right, he's floating there. Okay, so yeah, he's floating, he's doing his thing. Still not affected by the rock. And why do you think that is? Well, it's because our rock doesn't have a rigid body either. So I'll press W to select this component, physics, rigid body. Okay, pretty cool, right? Now, do we want these rocks to be affected by gravity? The answer is no, because if it is, it's just going to fall down, which is not what we want. So we need to turn gravity off of our rock. That will never be affected by gravity. Let's go ahead and play it now and see what happens. Okay, look at that. So did they hit each other? The answer is yes. And you're probably thinking that was pretty cool. Actually, it is kind of cool. It's not doing what we want it to do. That's not how Flappy Bird works. But it definitely worked. The two objects with rigid bodies are now being affected by physics, and their colliders collided, and then physics did their thing. So when two objects of different forces hit, they're going to go different directions, or they're going to interact however they're supposed to in the world of physics. But this is not the correct behavior for a game. So what we need to do is actually on this rock here, we need to mark it as is kinematic. And what that means is this object can affect other objects with physics, but it cannot itself be affected by physics, which is exactly what we want. These rocks are immovable, but they need to be able to affect our little zombie guy. So let's play and see what happens. I would hope that the rock would not move and the zombie would get knocked out of place. As you can see, it is working. Okay, so we've made some progress so far. We've got rigid bodies on our characters. Of course, the other rocks don't have them yet. And on our character and the rocks, or a rock at least. And it is affecting the physics of the zombie, which is really cool. So that's exactly what we want. Now let's go ahead and finish up these other two rocks here. Okay, we made the mistake of not making them a prefab. I made the mistake of not making them a prefab. So we're going to have to delete them and recreate put them back in their spots. But that's okay. That's no big deal. I'm going to save the scene, and then I'm going to click the prefabs folder, and then I'm just going to take this rock and drag it in here. So it is now a prefab. Then what I'm going to do, okay, is I'm going to select this rock, Command D, and I'm just going to move it about where the other rock was, right about here. Okay. And I just want to get rid of the rock that was already there. Okay, so let's make sure, yep, this is our prefab, that's right. And let's Command D again, and we're going to move it right about where the other rock is. Like so. And we're going to get rid of the old one. So these are all prefabs now, and you'll notice that each of these now has a box collider, and it also has the rigid body on here, which is exactly what we want. Okay, so our rocks are definitely doing what they're supposed to be doing at this point in time. Now let's go ahead and get our zombie. Let's get him jumping. Let's get him moving. So we're going to write some code to do this. So let's go over here to our scripts and go into our player script. So here's our code, and let's think about the problem that we want to solve. Whenever the jump is clicked or the button's pressed, we want to add some type of force to our character. We want to shoot them up, just like in real life. If you jump, it's a sudden force or impulse that moves you up in a short period of time, not the same as, let's say, a rocket where the fire starts coming out and it goes faster and faster and faster. That's a different type of force as an impulse force where it's just boom, you jump up like a jump, or like a Mario game where he would jump. So it's something to think about. You click, we want to add some type of force. Then of course gravity is going to do its thing as well. Because I have experience and I know what we're going to need to do, we're going to go ahead and create a variable up here for our rigid body. And we're going to say private rigid body. And we're going to call this rigid body. And I forgot that we should make this private as well too. All of your variables in C# and in any programming language, in most cases, should always be private. Okay, we don't want other classes like our object or whatever to be accessing those publicly. And so you may not understand why, but if you have any questions about it, what I want you to do is go do a Google search for the phrase, what is data encapsulation? It's called data encapsulation or data hiding, and it's going to help you create a safer, more protected application that has less bugs. So we're going to make a rigid body here, and what it's going to do is it's going to get the reference to the rigid body component that we added. Remember, anytime you do get component, it's finding the object or the component on the object, and that's what it's going to reference there. Okay, and of course we need to find it here in start. So rigid body equals get component rigid body, just like we've done before, and this is looking good. So when we click jump, we need to add some type of force. That makes complete sense. Okay, but we do kind of have a problem. Update. So update is good to use when you're not using physics. Okay, but when you're using physics, it's not good because update can it can go faster or slower depending on how fast the processor and graphics card is in the device that you're using or that your player is using. So what we actually want to do is we want to use fixed update. Okay, and let me pull open the scripts here or the documentation here for a fixed update. This function is called every fixed frame rate frame if the model behavior is enabled. Fixed update should be used instead of update when dealing with rigid body. For example, when adding a force to rigid body, you have to apply the force every fixed frame inside fixed update instead of every frame inside update. So if you added some type of physics force in update, you might just shoot your guy off into the moon because it's going so fast, whereas the fixed update evenly distributes the fixed frame rate, or it goes through every fixed frame rate frame, so you can evenly distribute the force or whatever you're applying to your physics. And it's very, very important. Anything with physics, you're going to want to use fixed update every single time. So if you're making a first-person shooter game and you're walking through a building and all of a sudden there's an explosion, and rocks start falling down, and they're physics rocks, those rocks themselves, not the player, but the rocks should be in a fixed frame update as they're coming down and things like that. So you can use both within your application. Just remember that's really important, and you don't have to understand it completely. Just know the rule is when working with physics, or rather working with rigid bodies, always use fixed update. Okay, super, super important. So let's go ahead and create that function now. I'm going to say void fixed update, like so. Okay, and what we're going to do now is we're going to actually detect when we're jumping we're going to save a variable to know when we're jumping because we don't want to do it here in update, right? So how do we know when to apply the force? Well, we could call a function, but that wouldn't make sense because we need to be doing it in fixed update. So rather what we're going to do is we're going to create a variable. I'm going to call this private bool, and we're going to say jump equals false. So it's a Boolean that we're simply going to say, hey, I just clicked the jump button. Now in fixed update, go do your thing. And you'll see what I mean right here. So when update's going on, okay, what we're going to do is we're going to go ahead and say jump equals true. And then over here in fixed update, we say if jump equals true, okay, we'll turn jump to false. Jump equals false. We'll turn it off now. Okay, stop it once it's started. And then this is where we can add the force to our object to give it some type of impulse or something like that. Okay, and so jump equals true. This looks good. And whenever we jump, we just want to make sure we turn the gravity back on. We don't want to start with the gravity on because we need the character to be there, ready to play. On Flappy Bird, the character's just floating there before physics get turned on. It's kind of the same thing. So we'll say rigid body dot use gravity equals true. If any of this ever gets confusing and you're like, oh my gosh, this is so overwhelming, all you have to do is pause this video and read the code. Okay, go from line by line, from top to bottom. Animator. What's an animator? I can't remember. Go to the documentations on Unity, search for animator. Same thing, go down through each line of code until you understand everything completely. This is one of the biggest mistakes that new programmers make, okay? They just kind of speed read. You can't speed read and program. If you're one of those kind of people that like skims through the chapters, this is how I used to be. I'd skim through the chapter just to get the gist of what's going on, like a speed reader, so I could basically tell my teacher, oh yeah, I read the book, I did it in a day, but I used my cool skills to speed read and kind of get a notion of what's going on in the story. You can't ever do that in programming. Get that out of your mind right now. If you don't understand a line of code, you need to stop what you're doing and you need to understand that line of code before you move on. Super important. Okay, so what we're doing here is we click once, plays the animation, that's what was already in there. We turn on the gravity, and then we say, okay, we're jumping. And that way in fixed update, which is already running, if jump equals true, then we can add the force. And so we set it to false because we only need to perform this one time, one click, right? And so what we're going to do here is we're going to go ahead and add a force. We're going to say rigid body dot add force, like so. And you can pass in a vector 3 or vector 2, or put them in manually here. We're just going to do a vector 2 because we only care about the x and y. That's completely fine. And let's give it a jump force. Let's say 100F. And as a second parameter, we want to set the force mode. Okay, it's what type of jump it is. And if you notice here, there's different force modes, and we talked about this already. What force mode here do you think that a spaceship would use? Well, it probably wouldn't be velocity change, some type of sudden change in velocity, and it probably wouldn't be impulse like a jump. It'd probably be acceleration, right? But we're not building a rocket. We're kind of more jumping, and this is kind of a standard, like a blend somewhere in the middle. And so I think that impulse makes more sense, right? Like boom, you're jumping, a sudden burst, and I think that makes the most sense. And these all have their different physics properties, and you can look up on the Unity documentation to see what each one of these does. Okay, force mode dot impulse. Okay, so we click jump, we set jump to true. Over here we set jump to false. We have already turned on gravity at this point, and now we can now we're applying a force every time someone clicks. Okay, let's go ahead and see if it works. Run the app. So physics should not be or gravity should not be enabled, but when I click, he went flying off the screen. And he's probably up there somewhere. Where did he go? Well, he's gone. Yeah, so clearly we added way too much force, or there's some other things we need to consider. And I think there are other things that we need to consider. Let's go look at our little zombie. All right. Player. Okay, so notice how there's these properties here. Now let's talk about mass. Okay, mass is important for certain reasons. Now it's important to understand a little bit about physics. Okay, if you drop a bowling ball and an apple from the Empire State Building, which one is going to hit the ground first? If you said they're both going to hit at the same time, then you're right, because gravity and mass gravity doesn't care about mass, okay? Everything has equal mass as far as gravity is concerned when things are falling down. So if you're thinking, oh, I need my character to fall faster, mass isn't necessarily going to help you out at all. It's not going to help you out at all. However, mass is important when it comes to force and impulse, right? Because let's say you put a rocket underneath a tractor versus a rocket underneath the bottom of your shoes, the same exact rocket, okay, with the same exact force. Which one is it going to lift up faster, you or the tractor? It's going to lift up you faster. So the force matters when it comes to mass, but it doesn't matter with gravity. Okay. Also, we got these notions of drag and angular drag. Now, drag and angular drag, we kind of talked about this, but let's do the same example. If I drop a bowling ball, okay, and a piece of paper, right? They have different masses, but gravity doesn't care about mass, right? Which one's going to hit the ground first? Well, of course, the bowling ball. The paper's going to flutter back and forth, and that's because the paper has drag. Okay, so drag clearly is important when we're slowing things down. Okay, and also gravity is important as well too. How much gravity is? If you're on planet Earth, okay, you are going to have a certain type of gravity. It's going to be different than if you had gravity on planet Jupiter. I remember reading somewhere if you if you were on planet Jupiter, you'd like weigh like twice as much as you weigh now because there's so much gravity. It'd be really hard to move. And so if you're building a game that takes place on Jupiter, okay, you can adjust the gravity like so. You wouldn't be running and jumping and floating through the sky. So I know that's a lot, a mini little physics lesson, but that's kind of how it works. So I do think we should increase the mass, because when he starts falling down, and when he jumps, we don't want him to go flying into the sky. That's what I'm trying to say. We don't want him to go flying into the sky. So I'm going to say 12. Let's just say 12 right now. Let's play the game. Let's give him some more mass. Okay, look at that. So same exact force, except he weighs a little bit more now, right? This is the example I used with a rocket under a tractor versus a rocket under a person. However, he kind of floats down really slow still, which I don't like. I just don't like that at all. Okay, he's just, yeah, I'm floating. But it's kind of cool, he's like, we're having fun now, like all kinds of fun. But it's still not quite what we want. And what I'd like to do is actually increase the gravity in the game, the entire world. So what we're going to do is we're going to go over here to Edit, Project Settings, Physics. And this is standard gravity is negative 9.81, I believe. We're going to change this, or whatever yours says is, I may have changed this. Whatever yours says is the default, but it's something around here. You want negative, right? If you want him to go up into the sky, like, ever have that worst nightmare? Like, you're looking up at the stars and you feel like you could get sucked into outer space. Like, that would be like the worst thing ever. If you want to make a game like that to embrace your childhood fears, take off the negative value here. And what we're going to do is we're going to say negative 16. Give it way more gravity than expected. It's our game. We can do what we want. Okay, so notice how he's not jumping as high this time. This is kind of cool. There's still some other problems, like if he starts falling faster and faster, the velocity increases, okay? Is that true in physics? If you drop a bowling ball from the Empire State Building, it's going to go faster and faster and faster? It absolutely is going to go faster and faster and faster. Which is why, if you jump off of 2 stairs onto the street, you're just a kid having fun. But you can't jump out of a 50-story building. You're going to die, and that's because your velocity will increase and it will kill you. So we got a velocity problem where he just keeps going down faster and faster, which makes it harder to click. Maybe that's how you want your game. That's not how I want my game. I just don't like it at all, and I don't like the drag either. I don't want him to have any drag. Okay, so let's turn off the drag. I'm going to say 0 and 0 on the angular drag. Okay, and I think what we need to do is we simply need to control the velocity. Okay, whenever we jump, I just want to turn off the velocity of the Y. So when he's falling, there's the velocity is increasing. And to show you what I mean, let's look at our code here and actually just print out the velocity. Okay, we're going to print out rigidbody.velocity.y. And we're going to see what happens. Okay, so if I play this, it's going to start off at 0, I'm guessing. I'm clicking, it's in the 13s and 10s, but watch as he falls. It goes down, down, and it starts going down into negative numbers, see? And it makes it really hard to click up, okay? That's not what we want. As soon as you click the jump button, I want that velocity set to 0, so it's like he's on the ground again. And that's not natural, right? A person can't jump in the sky and then jump again, but a Flappy Bird can, and that's what we want. We want to turn off that velocity the moment that we jump, okay? So let's go ahead and do that as well. We're going to say, and we're going to want to do it before we add the force here. So we're going to say rigid body dot velocity equals new vector 2. You could do vector 3, but we don't care about the z. We're just going to say 0 and 0. 0 velocity in the x, he's not moving forward or backwards, and 0 velocity up and down. We're just kind of resetting it to 0 so he can jump again, as if he just jumped off a platform in the middle of the sky. And that's how Flappy Bird works. And so let's play it. Jump. Look at this. This is nice. Okay, this is really nice, nicely coming together. It's still not quite perfect. We can, of course, adjust it and play around with it. But it's coming together. It's actually looking really nice. So one other thing, I don't like having this add force here as a hard-coded value here. So what I want to do is I want to make this a serialized field. So serialize. I like putting them at the top. In fact, this can be together. Serialized field, and we'll say private jump force equals, we'll give it a default value of 100. Just private float. There we go. Give it a default value. I like giving the player a default values or the editor, so at least you have something to work with. That way now the velocity sets to whatever you put it on there, and or the jump force, and you can increase it or decrease it dynamically. And it's really coming together here. I'm really liking what we're doing here. So let's just play it one more time and make sure everything is working as expected. It's jump, jump. You know, he's a cute little zombie. Yay, we made it past this one. And he might be too big to have actual fun gameplay. You could, of course, adjust that to your liking. Let's make sure physics are still affected. Oh, no, I hit it. Okay, so definitely physics is working here, right? Cool. So let's call this video done. Let's recap what we've learned. We've learned a lot. We've learned about rigid bodies. We learned that unless you have a rigid body on an object, it will not be affected by physics. You also must have a collider if you intend for it to be colliding with other objects. We set the is kinematic to true on our rocks because we don't want them having anything affecting them. We just want them to affect other objects. And then, of course, in our code, what we did was we detected the mouse jump, which we already had, or the click for the jump, and then we turned on gravity, and we set a local variable here called jump to true, so that way in fixed update, which you always must use when working with rigid bodies, okay, could know, oh yeah, we're jumping, so then it turns it to false. Okay, we're turn it off now, so we can jump again the next time. And then we go ahead and we set the velocity to 0. Okay, so the moment you click that button, we want to stop the Y velocity, like as if he's jumping on a platform in the sky, which is just how Flappy Bird works. And then we want to add force. Okay, and we did a jump force here on the Y, just an arbitrary number that we picked that feels right. And then we set the force mode to impulse. We didn't want acceleration, which goes over a period of time. We wanted an impulse, like a jump. And our game is really coming together now. We've learned a lot, and these things you're learning right now, even though it's a Flappy Bird game, you're going to be using them for every single game you probably ever make with Unity 3D. I mean, unless it's a 2D game that has absolutely no physics, you're going to be doing these types of things here. And of course, rigid bodies could be for anything. For rocks falling from a sky or from a building, to a player jumping, to whatever you want them to be. So it doesn't have to be a pure physics game in order to use physics, which is really cool. And so that's it. Mark Price at devslopes.com. Moving on and forward.